Good evening and welcome to USM News. I'm Gary Coldman.
And I'm Amanda Snowden.
On today's programme, the Met Office has announced that the Thermohaline circulation, the ocean current system responsible for Western Europe's temperate climate, has officially collapsed. It is suspected that the recent flux of fresh water into the North Atlantic that has resulted from the accelerated melting of the Greenland ice sheets is the main cause of the shutdown.
Scientists predict that in the next 24 hours, the whole of northwest Europe could be plunged into ice age conditions. Widespread panic has been recorded throughout the country, with extreme winds and flooding reported along the western coastline of the UK. Heavy snowfall and Arctic conditions have already swept across northern Europe, with areas in Scotland receiving almost a metre of snow in the last 5 hours.
Thanks to Hollywood blockbusters, like The Day After Tomorrow, the type of scenario just presented is what often comes to mind when considering the impacts of a complete shutdown of the thermohaline circulation. However, if this was to happen, would events really unfold like they do in the movies? If so, how likely is it that this could occur in the future, and when exactly is this all going to happen? These are the questions that we set out to answer as part of this documentary. First of all, we should explain what the thermohaline circulation actually is. The thermohaline circulation, which was first conceptualized by Benjamin Franklin in 1770, is a system of shallow and deep water ocean currents that operate much like a conveyor belt, with water sinking in higher latitudes towards the north and upwelling in southern oceans. This conveyor-type system is driven by the difference in densities between seawater in the northern and southern oceans. As warm water heated by the sun near the equator is transported northwards via the Gulf Stream, past the west coast of Europe and into areas of deep water in the higher latitudes of the northern Atlantic, it begins to cool, with a percentage freezing into sea ice. As water freezes, the concentration of salt in the remaining seawater increases, causing the density of the water to increase and therefore sink. This water then flows southwards in deep water ocean currents to the southern oceans, where the density of water reduces and upwells to the surface. There is evidence that there have been breakdowns of the thermohaline circulatory system in the past. One significant event was 8,200 years ago, following the final collapse of the North American and Scandinavian ice sheets. This allowed large volumes of fresh water to sweep into the North Atlantic, affecting the salinity of the ocean and preventing deep water formation. As a consequence, extreme cold and dry conditions prevailed across much of the North Atlantic region for a short period of time before the climate stabilised again. These cold conditions lasted approximately 160 years, with temperatures dropping almost 6 degrees Celsius. So, what are the chances this could happen in the future? Well, it is widely predicted that the strength of the thermohaline circulation will weaken within the next 35 to 85 years. The likely cause of this is the accelerated melting of the Greenland ice sheet as a result of increased Arctic temperatures related to global warming. In fact, the Greenland ice sheet is already discharging 210 cubic kilometres of fresh water into the Arctic waters every year. A collapse of the thermohaline current is likely to have significant adverse environmental impacts in northwest Europe. Without the warm water being brought up from the south, temperatures are expected to plummet by between 5 and 12 degrees Celsius in parts of Europe. This widespread cooling is predicted to increase regional drought potentials as more water is stored as snow throughout the winter. This causes the additional risk of flooding in the spring from the snowmelt. A lack of thermohaline current is predicted to cause substantial changes to atmospheric circulatory patterns, increasing the intensity and severity of storms. Climate models indicate that following a thermohaline collapse, areas of northwest Europe will become more vulnerable to these newer storms. Drought, flooding, and storm severity, along with the additional concern of sea level rise, is predicted to have a detrimental effect on biodiversity. Habitat size and functionality would be degraded by these environmental changes, with many scientists predicting a southward shift in ecosystems.
The collapse of the thermohaline circulation will affect many aspects of how we live our lives today. There'll be many detrimental impacts on health, particularly to vulnerable populations such as the elderly and the young. However, it isn't all bad. The reductions in temperatures will reduce the spread of climate-sensitive diseases such as Lyme's disease. It isn't just vulnerable populations that will be affected. Industries that are reliant upon specific climatic conditions will be susceptible as well, such as agricultural industries. The French wine industry is an example of this. Wine is France's largest export and in 2000 was worth over €9 billion. Vineyards are widely spread over France and are prone to failure with the presence of frost or worse, snow. As the cold weather migrates southwards, the proportion of successful vineyards will dramatically reduce, ultimately leading to a complete collapse of the industry due to strong winds and freezing conditions that are predicted. Not only will the land become unsuitable for viticulture, but high latitudes will also become unsuitable to agricultural crops, increasing the cost of food within Northern Europe. France are heavily reliant upon water within the energy industry through the use of not only cooling water, but for hydropower as well. Hydropower supplies Europe with 179,000 megawatts per annum. France is one of the largest producers of this, with 14% of its current energy mix coming from hydropower. Due to the freezing temperatures, the capacity for hydropower will reduce, requiring an adjustment in the energy mix for many northwest European countries. With regard to mitigation, globally, the aim is to stabilise levels of greenhouse gas emissions in the atmosphere. In order to do this, we must reduce greenhouse gas emissions and enhance reservoirs and sinks. In northwest Europe, the focus is on transport and energy sectors, which are key to enabling reductions in emissions. By investing in and developing renewable energy technologies, as well as low-carbon transport systems, it will be possible to reduce emissions to a stable level. However, climate change mitigation requires a global effort. As emissions are not confined within country boundaries, this ultimately limits the potential of mitigation as countries are not legally obliged to reduce emissions, and therefore, reductions made by some countries are often offset by increased emissions in others. There's also a possibility that even if emission targets were met, temperatures may still rise above the 2-degree threshold, beyond which dangerous climate change is almost certain. Therefore, nations will have to adapt. However, this too is no easy task, as the large uncertainty surrounding the timing and extent of thermohaline collapse limits the options available for key decision makers. It is therefore widely acknowledged that the best current course of action is to monitor and track changes in the condition of the THC until better understanding is obtained of how events may unfold. This can be achieved through the use of global climate models. These use information about previous and current climate to predict how climate systems may change in the future. However, will monitoring be enough? Or is it possible that by the time the signs become visible, it will already be too late? One thing is for certain, this question must be answered soon in order to limit the potential impacts of a thermohaline collapse.